Mhm. There are many, as I said before, that there are many applications of the Bernoulli equation and the continuity equation. On the top figure, you can see that this is a golf ball moving in the air and the air. When you hit the golf ball, and due to the shape of the club, you can make the golf ball spin. Okay, you can make the golf ball spin, and due to the spin of the golf ball, it will disturb the pattern of the flow of the air around the ball. For example, in this figure, the direction of the spin is in this direction. In this direction. Okay. So there is a friction between the surface of the ball and the air. The dimple on the ball, you may wonder why the golf ball have to have the dimple on the surface. The dimple on the surface increase the friction between the ball and the air. So it means that if the ball spins like this, the friction between the surface of the ball here and the air, in this case, the ball the ball move in this direction. The ball move in this direction. Okay. So it means that equivalently we can say that the air moves to the left. Okay. So if you look at the line of flow of the air, it will flow from the right to the left, and the ball also spin or rotate. And if we look at this side, you can see that the direction of the motion of the ball, the surface of the ball, is opposite to the line of flow. So the friction will reduce the velocity at this side. Okay, so if we denote the velocity here as a v1, okay, we can see that v1 will smaller, the magnitude of v1 will smaller than the magnitude of the fluid before it hit the ball. But if we look at the top surface here, you can see that the direction of the motion of the surface is the same as the direction of the line of flow. So it means that the friction at the top surface will increase the velocity of the fluid. Okay, so if I denote the velocity of the fluid at the top surface, we will have that V2 will be larger than the velocity of the air before it hit the ball. And together we will have that V1 is less than V2. Okay, V1 is less than V2 from the spin of the ball. And similar to the case of the airplane wing, we will have that the pressure at the bottom surface, the pressure here, if we denote it as a P1, and the pressure at the top surface, if we denote it as a P2, we will have that P1 is larger than P2. Okay, so if P1 is larger than P2, we will have the net force that push the ball in the direction from the bottom surface to the top surface, which is this force. Which is this force. And this is the same as in the airplane wing. We can call it the lift force, or that act on the ball due to the pressure difference. But when the ball moves in the air, we also have the drag force. So the net force is something like this, and the result of this force is that it makes the ball move in a curved path, for example, like this. Okay, so you can hit the ball in a specific way or in a certain way, and you can make it move in a curved path, and that is due to the spin of the ball. We can do this also if you look at the football match. Okay, you can see that the football player, the professional football player can make a curved ball, because when they kick the ball, they do not kick it directly, but kick it in one side to make the ball spin. Okay, and from the spin of the ball will move in a curved path, and this is directly come from the principle of fluid dynamics, the Bernoulli equation and the continuity equation.